This is mm, the last part for rate of change. This part of the rate of change, right, is dealing with the mensuration formula. So you will see all the formulas that you have learned in the lower side. But sometimes it may not be provided during exam. So you might need to memorize some or almost all the formulas. Okay, so because this part you will be dealing with volume and area, we will be using this standardized symbol. So take note of the symbol that we'll be using, unless, right, it is otherwise stated in the question. So sometimes the question may want to use X as a radius, so you stay with it. Okay, or else, if the question never state what should be the symbol, you can use this generic one. So this will be the formulas that you may or may not be given. So you have to memorize into the exam. In O level, I don't think this one is given. So you just have to memorize it. Okay. So in this related rate of change or connected rate of change, we will still be following the 5 steps. So I'll be showing you the three basic questions, and then I will show according to the 5 steps. So if you still recall the 5 steps, you can take the previous teaching worksheet. The first step, you need to have the information. So actually, if you look here, the area of circle is the information. So the area of circle is this formula. So that is my information. And this is area is increasing at this rate. So this is the dA dt. So some students, right, they will tell me, I don't know what is the notation. If you don't know what is the notation, you look at the units. You see the unit centimeter square. So centimeter square is the units for area. So that's why it's the A. And S is second. So that is time. So that's how you decide. So after I know my information, I need to know what am I calculating. So I'm supposed to calculate the rate of change of radius. That means I'm supposed to find dr dt when the radius is when the radius is 6. So first step, information. Second step, your aim. Third step, the previous third step was the dy dx. Right now, obviously, you couldn't have the dy dx. So you got to be using this. So this is A and R. So when you differentiate, you got a dA dr. So previously, it was definitely dy dx, but right now it's not. It's dependent on the mensuration formula that you are using in your step 1. So in my step 4, I need to have my dr dt. So I can use a generic one. The generic one will be like this. The generic one will be like this. Again, you can see that this dr is cancelled away. So with this generic formula, I insert whatever I have. dA dt is this one. dA dr is whatever I just differentiated. And I'm supposed to find a dr dt. So I'm just going to be dividing over. So eventually I will get a very nice formula. So same like the previous method. Okay, I will want to get a formula first. Then I do a step 5. I substitute the r equal to 6 into the formula. So the r equal to 6 is always the last step. So please try to follow to avoid confusion. Okay, so it's the same 5 steps. Okay, so in question 2, I got a radius of a sphere. So So this is the radius of a sphere. And it is increasing at this rate. Okay, so my information will be the sphere. In the sphere, right, if you look back at the formula, it can either be volume or surface area. So which formula I'm going to take? So you might need to look a bit further because they are finding the rate of increase of volume. So I should be dealing with the volume of a sphere. So the information will be the volume of a sphere. And the radius is increasing at 2 centimeters per second. And I'm supposed to find the v dt when the radius is 3. So your third step will be the chosen formula, and then you do a differentiate. And then your fourth step will be get a formula here. So this one can be a generic formula for volume. So in this case, it will be a dv dr times a dr dt. So dv dt is my aim. So this is the formula for dv dt. My dv dr is this. My dr dt is 2. So my dv dt ends up to be a very nice formula. When I got a very nice formula, then I put in my r equal to 3. Okay, so you punch out the 3SF. Okay, by right, you should punch out the 3SF. Unless the question says state that you leave it in terms of pi. Okay, so in this one, I'm using the volume of sphere. Here, I'm using the area of a circle. So every question can have different formula. So you will see a variety in the rest of the practice question. Okay, so in this question here, we are dealing with a square. So we are dealing with a square. So you might want to draw a square first, and then you can use the length as x. So we are interested in the area of a square. So that is the information. So according to my diagram, the area is x squared. And there is the dA dt. So this is area increasing at this rate. So that will be 10 centimeters squared per second. And my job is to find the rate of change in the length. Length is x. So my job is to find dx dt when the area is equal to 4. So I'm still following strictly the 5 steps. So with the chosen formula, you do a dA dx. And then in the step 4, you need a formula. So you can do a generic formula, dA dt. Okay, you can see that this part is being cancelled. So this one can be a generic formula. So this is the 10 centimeter square. This is the differentiated answer. Okay, so from here you can get a formula. So that will be the formula for dx dt. Sorry, I wrote wrong. So that will be the formula. So the formula is telling you to substitute x, but the question doesn't give a x. So go to step 5. You couldn't be substituting area inside. So you got to use the formula. You use the x squared. That means x squared is equal to 4. X will be 2 or minus 2, which you will reject. So you get the x that correspond to that area, and then you substitute into your formula. Okay, so I hope you can see that I'm still using like the 5 steps. Try to go with the 5 steps. Unless you are okay with your own sequence. But if you're always getting confused, please stay with the 5 steps.